In this video, let's have a look at how we can work more efficiently with MySQL using MySQL Workbench as well as SQL scripts. First, let's create a new schema in our database. Go to the top toolbar and you will find a Create New Schema button. Click on it and let's name our new schema Demo. Click Apply. What you will notice is that MySQL Workbench provides us with mainly two ways of working with our MySQL database. The first is we can actually write SQL scripts, such as this, create schema demo, and execute these scripts directly in the script editor. Or we can use built-in tools, such as what we just used, to generate these scripts and apply them. We'll see more examples of this in this video. Let's apply this. Now, in our schema window, what we will see is we will have a demo schema. Let's double click it to make it the active schema. We'll see right now that we don't have any tables, so let's add a new table. Again, at the top toolbar, we'll see the Create a New Table button. Let's click on it. What table will we make? Imagine we're maybe a store that takes in a whole bunch of orders, and we want to keep track of these orders in our table. So we'll name our table Orders. In this view, we can also define the columns that we will have in this table. The first column name, we want to track of our order ID. Okay. For each column, we can define the data type, which is really the type of data that will be stored in this column, as well as column attributes. Going from left to right, we can define if a column is a primary key, not null, unique, binary, unsigned, zero filled, auto increment, or generated column, as well as the default expression, such as null. So for this order ID column, we will use it as the primary key. We know it's never going to be null, nor do we want it to be null. And let's also check off the auto increment option. Okay. Next, let's give some extra columns to our table. About customer ID. So the ID of the customer who actually placed the order. We'll make this one an integer as well. Next, we'll have item. We'll keep this as a variable char at 45. And finally, let's have a price. And make this one also an integer. Okay. For example, if there was no price submitted, we'll say that the default expression for these columns will be null. After we're satisfied with the columns we're going to add into our table, we can click Apply. Again, we'll see the SQL being auto-generated by MySQL Workbench. So you can also write this exact same script yourself, run it, and it will also create the same table. Let's click Apply to create our table. Now in the Schemas bar, if we drop down tables, you'll notice we now have an orders table. A note in the Create Tables window. You can actually specify more table attributes than just defining the columns themselves. We can create additional indexes. Indexes are a great way to make sure that your query efficiency of your table is high. So think about how your data is organized and try to create indexes where possible. We can also define foreign keys, such as our customer ID should link to a customer's table, and this is where we might define that relationship. We'll also be able to create triggers, as well as partitions, as well as more additional options. We will cover these in the later parts of our video. Now, let's see some common operations you might want to perform and interact with your table. As we saw before, in order to work with a table, we first need to make the schema active. The SQL script for that is use and schema name. In the query editor, you can use these buttons to execute your scripts. So the lightning bolt executes every script that you have in this window, and the lightning bolt with kind of a cursor on top will only execute the current line. As a shortcut, you can also use Control-Enter, and it will execute the query that's under your cursor. So what you can see is that on the bottom, we now have used demo in our action output. So the first thing we might want to do is we want to see the data that's currently in our orders table. To do that, let's run select star from orders. Hit Control-Enter. We see that in the results output, we have all the columns of our table, but there's no data. We can actually add data directly in this view right here. Double click in the first box. Let's say customer ID is 1. Item, maybe the customer ordered a pizza for a price of $10. Notice that I did not enter anything for the order ID, and that is because we defined order ID as an auto-incrementing column. That means when we enter data into the orders table, MySQL will automatically assign an incrementing ID to the order ID column, so we don't have to worry about it. Let's add another row so we can demonstrate. After we have the data that we need, we can go to the window and hit Apply. Again, we see the SQL scripts that we otherwise might run to insert data into our table as well. Hit Apply. So now, if we run our select statement again, we will see the data that we just inserted. We might also want to update data. Let's say that pop for a price of $12 is way too expensive, so let's fix it. We can also edit table data in place, just like we added table data in place. So let's change it to $3. We can click Apply and finish. Now we will see that our orders table, just run the select statement again, has pop at 3 instead of 12 as we had before. Something that is worthwhile setting up initially is that MySQL Workbench has something called Safe Update. Let me demonstrate to you. If I try to update orders, set price equals to, let's try to change it, maybe our pop increased, where item equals pop. Okay. This is the exact same thing that we just did in our output window here. And if I try to run the statement, what you'll see is that in our output, we have an error. And the error is you're using safe update mode and you try to update a table without aware that uses a key column. Let me just bring up the orders table back again. So basically under safe update, we're not allowed to make changes to our table data unless we reference the order ID. We can obviously do that, but sometimes it just becomes a hassle. So we can actually turn this off in our preferences. Go to the edit window, preferences, and then under SQL editor, scroll all the way down, we'll find a checkbox for safe updates. Uncheck this option and click OK. To have this take effect, we actually need to restart Workbench. Let's try running our update statement again. You can see this time it succeeded. So let's select from our orders table just to make sure. Pop is now at $4. Finally, another useful thing to note is the selection limit. So for each select statement, your editor actually gives a default limit. So you can choose to limit to 1,000 rows, 10 rows, or don't limit. To ensure you're getting all the data from your table, usually you might want to set it to don't limit so you know that everything that's returned is everything in your table. Now let's get into some more advanced functionality that will help you be more efficient. First is triggers. Right-click on our orders table, choose Alter Table. This will get into our table configuration window that we've seen before. Let's go to the Triggers tab. Triggers are essentially logic that you can run on each row of your table when the row gets inserted, updated, or deleted. And you can run trigger before the row gets inserted, which means the result of the insert will be modified, or after the insert, maybe if you want to actually modify another table than the one that you're inserting. Let's quickly show you an example. Clicking the Add button, we'll get a template for creating a trigger. What you can see is we're creating a trigger on demo, orders before insert on orders. Okay. So this means for each row of the orders table that now we insert, this logic will run before insert. As an example, let's set new.price is equal to new.price times 2. This doesn't make a lot of sense in the real world, but what we're essentially doing is for every new price that gets inserted into our table, we're going to multiply it by 2. Let's hit apply, so we add this trigger. I'm just gonna copy this so we can talk a little bit about this code. Click finish. First, let's see our trigger in action. Let's go back to our triggers table and let's try to insert a new row. 3 wings, maybe 15. Hit apply. Okay. Immediately, you saw after I hit apply, the price turned from 15 to 30. So our trigger of multiplying the price is working. Let's open a new editor so we can talk about this trigger code. I'll paste my previous copy. So this is very useful because a lot of times you don't want to be editing your triggers because this is just a demo, so it's one line, but often our triggers can be very long and you want to keep track of your trigger code somewhere else. So this script will allow us to update our trigger without having to use the other interactive window that we saw before. In the first line, what we do is we check if the trigger already exists and we drop it. Because otherwise, if you try to create a trigger in the same name, there will be an error. Also, we set a delimiter. So usually, MySQL is delimited by the semicolon. However, in this case, because our trigger code includes everything, and maybe it also includes other statements as well, we don't want MySQL to be executing these statements one by one. We want to execute it all together. That's why we would temporarily change the delimiter to $2. And then after we finish our script, we change the delimiter back to the semicolon. The second advanced functionality that will help make your table to be more efficient is partitions. Right now, our orders table only has 3 rows. But imagine your shop got really popular and you run it for a really long time and your orders table become huge, maybe thousands or even millions of rows. At that time, querying for a certain row or aggregating might become slow. Partitions help us to create different partitions in our table via some index, such that we can actually query only a part of the table instead of all the data in it. Let's create a new editor. I've already created some partitioning code. Let's have a look. So we're altering our existing table, demo.orders, and we're adding a partition, a range partition to be exact, on the column order ID. Based on the column order ID, we're creating 5 partitions. partition named P0, where order ID is less than 20, P1, where order ID is less than 40, so on and so forth. Because we know there will be exactly 20 orders for order IDs under 20, under 40, this is a great way to divide our table into equal-sized partitions. Let's run this query. Now we have successfully created partitions in our table. Of course, since we only have 3 rows, all of these remaining partitions will be empty. To see the partitions that we just configured, let's go back to our table configuration view and go to the partitioning tab. What you'll see is now we have these partitions P0 to P4 defined in our table. We can select data from individual partitions using the partition syntax. Select table from start orders, just like we did before. Now add partition, bracket, our partition name. Let's do P0, because this is the only partition that will have data in it, because all of our order IDs are less than 20. Let's run this select statement, and we do see all of our orders that we inserted before. If we try to actually query from P1, for example, we will get no data because we don't have any order IDs that is greater than 20 or less than 40. The final feature, or rather requirement, is something that we run into all the time, and that is we might want to import a lot of data, let's say from a CSV, into our table. So how do we do that? There's a couple of ways. The first is we can use Workbench's import function. We can also use a SQL script to load data directly into the file, or we can create our own insert queries to insert the data. Let's go through each one. Go to the orders table, right-click, and select Table Data Import Wizard. It will prompt us to choose a file. I've already created a CSV file with some data. Let's have a look. What you can see is in the CSV file, you want your columns to be exactly what you have in your table. So in our case, order ID, customer ID, item, and price. Note the order ID does not start from 1 because we already have some data in our table. We'll save this file, close it, and we'll browse for this file and open it. Click Next. We'll choose to import the data into an existing table. You can also create a new table based on the data. Then we'll choose how each column in our CSV matches with the destination column in our table. Because we already matched everything exactly, we can go directly to the next step. We're done importing. Now, let's go back to our original select statement, run it. We have the new data that we just inserted. So this works really well, and it's a quick and easy way to insert data into your table. But if you had something like 10 million rows, this process will get very slow. So this is where the SQL script comes in. Let's delete these rows for now. Open a new query editor. I have another script prepped. Let's copy that in. What this script does, it will load data from the MySQL local upload directory. We'll talk a little bit later on what that is. Data.csv, so remember that is a CS file that we just saw, into the table demo.orders, where the different fields are terminated by a comma. So for CSVs, that's usually the setting. The values are enclosed by double quotes. So sometimes you might have single quotes in your data, so this is really important to specify. And then our lines are terminated on /r/n, which is the new line character for Windows systems. Then we'll also ignore one line because that is the line where we specified our column names. Let's run this query. We have an error, and the error says the MySQL server is running with the secure file privilege option, so it cannot execute this statement. What this means is that the MySQL server, for security reasons, will only upload files from certain directories. To find out which directory this is, or set it to another directory, we can have a look at the system variables. Go to System Variables, and let's search for secure. And we can see that there is a secure file privilege option with the value to the upload folder of your MySQL server data directory. Let's move a copy of our data file into this upload directory and copy the file path. Go back to our load data query and add the file path to our data to specify that this is where the file will come from. For Windows, note we'll have to use double backlashes in order for this URL to work. Let's run our query again. This time, it is successfully uploaded. Load data in file is a lot more efficient than running inserts one by line, and if you have data that is very huge, this is usually the best option. Let's go back to our select statement. You can see that we have the new data. The final way to loading data into a table is creating our own insert statements. This is useful when your data needs to be transformed. For example, you have dates that are formatted incorrectly, or if you have, for example, apostrophes in your items that needs to be pre-processed. Let's see how we might do that. First, we'll delete these rows again. Let's go back to our Excel file. So first, we want to create parts of our insert statement. For this methodology, we're going to use a combination of the insert statement and the concatenate function in Excel. Let me show you another trick. Open a new query editor. Go to our orders table and go to Send to SQL Editor, Insert Statement. This will give us a template insert statement for our table. We'll take out the placeholders here because we'll insert those ourselves. Put these into one line. Remember, order ID is something that is auto increment, so we can delete it. Let's copy this. We'll take this last part. So first of all, customer ID is an integer. Okay. So the customer ID will go here. We'll give it a comma. Very soon, you'll see what I'm doing here. Then we have item, which takes apostrophe. Now we have all the parts to our insert statement and our data. Let's see how we put it all together. So using concatenate, we can put strings together. What you'll see is this is one line of insert. Okay. So we're inserting 14, ice cream, and 5 into customer ID, item, and price. The beauty of this methodology is we can apply it to multiple rows in Excel very easily. First, let's change this formula. So we lock our reference strings. Now we can simply propagate the formula. Let's copy that. Go back to our query editor. Paste all our insert statements in that we created. Now we can simply run the entire script and we get all the rows inserted. This gives you a lot of flexibility in terms of how you want to transform your data and how you want to construct your insert statements. Just to make sure, let's go back to our select statement. We can see our new data was inserted. Hope you enjoyed this video.